It's recorded?
Yes, it is recorded.
Oh, yeah, that.
Some of our self
Okay.
yesterday.
That's not very, I don't know off the top of my head.
Yeah, me too.
But you know everything.
Well, not quite everything. So I think, yeah, we got down to the point where we found that
We
all
found
of
all.
these, yeah.
Everyone rushed it up. No, we must find 8. And that's 1.85.
All right, I think we got to this point yesterday on this problem. Okay, we found that R was about 1.853. Right. So from there, then, did we still need to check whether that was a min or a max?
Yeah.
All right. So put that on a sign chart. So 0.853. What was my?
Your derivative plus 4 pi r minus 80 divided by r squared.
Thank you. So if I plug in a value less than 1.853, and say 1, but 4 pi minus 80, that's negative. If I plug in a value greater than that, it's going to be positive. So, do we have a min or a max?
I have a question. Okay, so this you're trying to use the least amount, so it's obviously zero.
Right.
Like, what if you would have gotten a maximum for this? Or is that never going to happen?
So, that could happen. We're going to look at an example today where that will happen. In that case, if we're looking for a maximum and we get a minimum, that's where we'll have to check endpoints. It could be an endpoint where that min or max would occur. All right. So this is a min. Okay, that is what we want. So 1.853 is my radius. What do I need to do to find the height then?
Plug it into the
Yeah. So this was our volume formula, right? Our constraint. So I'm going to take this 1.853 and plug it in for R to solve for H. So 2 times pi times 1.853 squared times H equals 40. Divide both sides by all of this. Squared. What do we get for that?
Wait, why is this pi there? Those two are square root of 8. Because volume
So what do we get for this? That doesn't sound right.
No, it doesn't. Okay, this doesn't look right either.
Okay, just get a calculator. We're obviously not doing it for me.
Well,
Lisa.
I want you guys to be able to plug this into a calculator correctly.
I got 1.854.
1.854.
Yeah, I mean, we could reduce this to 20 over pi times 1.853 squared. So, what are we getting, 1.854?
Yeah, she said that was literally my same. You're telling me if I take a wild guess and did not have to get step times
So, the dimensions are 1.853 for the radius and 1.854 for the height. okay with something like this? Sorry.
It's not like your fault.
Yeah, we are given a unit, so we should tack on inches for both of those.
So are the dimensions just 1.853 and 1.85? Well, then you're going to solve for the surface area, or you just.
Well, so the question just says, what are the dimensions? It doesn't actually ask for the surface area itself. So the answer would just be a radius of 1.853 inches and a height of 1.854 inches. Okay? Other questions on something like this? All right, then get out that other sheet that we did a few homework problems on.
Yeah, she would have later, like, a day now. I think she got used to that. Just need it. I always think so, like, Timmy's 20. Timmy doesn't turn 21 until April 1st. Having a great time.
All right, we're going to start with number 7. Yes, we're not going to do all the problems. Okay, on number 7, we're taking a piece of wire, 40 centimeters long, and we're cutting it. One piece is going to form a circle, one piece is going to form a square. So first, this is a two-part question. First, I want to find the lengths of the two pieces that will cause the sum of the areas of the square and the circle to be a minimum. And then second, make it a maximum. So what's going on here? First, what am I trying to maximize or minimize? Right, the area. So what should my first equation be? Yeah, area of a circle and area of a square. Right? So if we can draw a picture and say this is just a circle of radius r and a square. We can give whatever variable we want for the lengths of the sides of the square. I'll just call them x. So we can say pi r squared plus x squared.
Okay, I was thinking, like, I thought area of the circle was radius squared times pi.
Yes, it
It
is.
said pi.
Okay, so how do you know
So the other piece of information we're given is that this piece of wire that we're cutting is 40 centimeters. Right, so whatever this is has to equal 40. So what is that going to be? What am I talking about if I'm talking about the length? Perimeter, right. So I want the perimeter of the circle plus the perimeter of the square. So the perimeter of the square would be 4x. What about of the circle? Diameter times pi. But since we wrote this first part in terms of r, yeah, 2 pi r or 2 r pi. You should absolutely know what the circumference of a circle is, yes. Area and circumference of a circle, yes, you were expected to know that. So now what? I've got my 2 equations. What do I do now?
take the one that has 2 variables.
Well, they both have. Oh, I guess this one has 3 variables. Yeah. All right. So take this one, solve it for one of the variables. Which one should we solve for? X. Okay. So I'll subtract the 2 pi r over and divide by 4. Right. We could simplify this a little bit. We don't have to, okay, but we could divide everything by 2 and just make this 20 minus pi r over 2. Okay, again, we don't have to do that, okay, but it might make the arithmetic for the rest of the problem a little bit simpler. So now we want to take this and plug it in for x up here. And I'm taking this 20 minus pi r over 2, plugging it in for x. So we'll get our area function is pi r squared plus 20 minus pi r over 2 squared. Now we want to take the derivative. So we can say a prime is 2 pi r plus, how would I take the derivative of this? Yeah, we want to use chain rule. Right? So 2 times, don't change the inside, then times the derivative of the inside. Do I have to use quotient rule here? Right, we're just dividing by 2, which would just be the same as multiplying by a half, right? So the derivative here, right, if I think about this as 1/2 times 20 minus pi r, right, the derivative here, I could even simplify this a little bit further and just make this 10 minus 1/2 pi r. So what's the derivative of that? Negative 1/2 pi. Right? The derivative of 10 would be nothing. The derivative of negative 1/2 pi r would just be negative 1/2 pi. Now what? Sure, we could distribute. So we could simplify this and make this 2 pi r plus, now these 2's would just cancel out, right? And then I can distribute this negative 1/2 pi through. So 20 times negative 1/2 pi would be negative 10 pi. And then negative pi r times negative 1/2 pi would be positive 1/2 pi squared r. Okay, now I'm setting this equal to 0, right, to find critical points. So how do I solve this?
So many pies.
Yeah, everything has a pi in it, so I could divide everything by pi. I mean, we could, but then this would become a 4th, which would be kind of ugly. So then we have pi r. Yes, we can cancel a pi out of everything. Now what? Sure. We can take the 10 over. So this is 10 equals 2r plus 1/2 pi r. So now we can factor out an r. About out of room here. So we get 10 divided by 2 plus 1/2 pi for r. So, I mean, that is the exact number, but we could put it into the calculator to get a decimal. So, what would that be if we get a decimal for that?
This would be 100. Right? So yeah, this would be on a calculator, right?
Probably, yeah. 2.800. Is that what everybody else got?
Because
Round to 3 places.
even It's C or something.
All right. Now what?
Now we have to do the
Yep. Let's put this on a sign chart. So 2.8 on my A prime sign chart. So if I plug in a value less than that, let's plug in 1. All right, so I can plug it into this version here. And if I plug in 1 for R, I'll have 2 pi minus 10 pi plus 1/2 pi squared. So that's going to be negative. And then if I plug in a value greater than that, say 10, I'll have 20 pi minus 10 pi plus 1/2 pi squared times 10, so 5 pi. So that's going to be positive, right?
Wait.
I mean, right off the bat, we can just see if I plug in 10, I'll have 20 pi minus 10 pi plus some positive number, right? So that's going to be positive. So is this a min or a max? It's a min. Is that? No, not for these. Yeah, I guess. Yeah. All right, so this is a min. So what do I still need to do?
You need to plug that number into that number.
Which one? They both have multiple variables. The top one?
No. I don't know.
Which equation should I plug this 2.8 in for R to solve for X?
Oh, it's the one that equals.
Why? Yeah, if I plug it in here, I only have one remaining unknown, right? So I'm going to plug 2.8 in, so 40 equals 2 pi times 2.8 plus 4x. So I'll subtract, I guess we could get a decimal for this. What's 2 pi times 2.8? 17.593. So we're subtracting that over, and then I'll divide by 4. So if I divide that by 4, what do I get for my x value? 602. So are those my answers? 2.8 and 5.602? Have I answered the question? Well, just for part A. We have to find the perimeter. Right? It says find the lengths of the two pieces. Right? It's saying we're taking a 40 centimeter long piece of wire and cutting it in one spot. Okay, so we need to find what the entire perimeter of each of these pieces are going to be. So it wants the lengths of each of the two pieces of wire. Right. So I'm going to take this 2.8 and plug it in for R in the 2 pi R. Which we already did right here. We got 17.593. Right? So one of the pieces, say the first piece, well, I'll say circle piece. Right, yeah. So the circle piece, 17.593 centimeters, and square piece would be 22.407. Well, yeah, I just subtracted that from 40. So, or we could have taken this and multiplied by 4. If we take this and multiply by 4, though, we would get 0.408. Okay. Are we okay with that? So we found our minimum area. Part B, though, says find the maximum area. Well, the only critical point we found was a minimum. So the endpoints. Okay. In this scenario, what would endpoints mean?
0
Yeah. Right. If my piece of wire is 40 centimeters, that means that the two endpoints are 0 for one of them and 40 for the other, and then vice versa. Right? So what we want to test is, well, if I make this length 40, or if I make this length 40, which one's going to give me the bigger area? Okay. So how do I test that? Yeah. We would set the perimeter of each equal to 40 and solve for each of these variables and then find which one gives us the largest area. So first, if I want to test the circle, I would say 2 pi r equals 40. Divide by 2 pi. So what's 40 divided by 2 pi? 20 over pi.
6.366.
6.366. So we're trying to maximize area, right? So then I would need to take that radius and plug it into my area of the circle. So area would just be pi times 6.366 squared. What does that give me? What was it? 316. So if we devote the entire length of this wire to the circle, we would get an area of 127.316. Now let's figure out what the area would be if we gave it all to the square. So, I mean, we don't really need to write down the solving part, just figure out the length of one of the sides of the square, right? If the perimeter is 40, what's one length of the side of the square? 10, right? I'm just taking 40 divided by 10. So then the area of the square would be 10 squared, which is 100. So how do I answer the question? What gives me the maximum area? Circle, right? Devoting all of the wire to the circle would give me the maximum area. Well, the area of the square would just be 0, right? If we're giving all of the area, or giving all of the wire to the circle.
So how do you write it to justify?
So we could just say I mean, if you want like a long explanation, there are no critical points that yield a maximum. Therefore, we would test the endpoints. And the two endpoints would be giving all of the wire to the circle or giving all of the wire to the square. Between those two options, giving all the wire to the square yields the larger area. Yes, giving all the wire to the circle, not the square. So, one of those things that we figured out yesterday, maybe the day before, I don't remember when, but if we are making a rectangular enclosure, a square will always yield the greatest area. If we are making an enclosure of any shape, a circle will always yield the greatest area. Okay. Questions? All right, I'm going to do one more together here. Let's see. I'm going to do number 13.
You say negative.
Alright, so on this one, we've got a tank with a rectangular base and rectangular sides, and there's no top. Right? So it's like a fish tank. It's got no lid on it. Okay? It's to be constructed so its width is 4 meters and its volume is 36. So we're given a couple of parameters right off the bat. Building the tank costs $10 per square meter for the bottom, and then $5 per square meter for all the sides. Right? So they're some type of different material. And we want to figure out how to minimize the cost of the tank. Okay? What thoughts do we have?
Okay.
Yeah, let's draw a picture first. Right? So this is going to be a rectangular prism. Right? So we're saying we know for sure 2 things, right? We know that the width is 4. It doesn't really matter which dimension I make the width. We can say that that's 4. Right? And we know the volume is 36. We're given that much information. Right? So what am I trying to minimize here?
The cost.
The cost.
And so I can do it in ways. Well, okay, first we have to write down the equation for volume, right?
Yeah, this is definitely going to have something to do with volume. Right? So we don't know what the length or the height are, but we know the width. So I can just assign those variables. Right? We can just call them X and Y or L and H, whatever you want to call them. I'll call them X and Y. So my volume, how can I set up a volume equation? And we know V too, right? So we can say 36 equals 4XY. So now what? Yeah, we need to figure out our second equation here. Yeah, I mean we could call it M or so. Like, what are we trying to come up with here? Like, we're trying to minimize the cost, but what does that mean in terms of the geometry of this problem? Yes, I just said geometry. There's a lot more geometry than triangles. Right, surface area is what we need here. Right? So I can express the surface area as the bottom plus all 4 of the sides. Right? I don't need a top. We're told it's an open top, so we're going to have 5 pieces that we're collecting here. The bottom. How can I express the area of the bottom? 4x. So yeah, the front and the back will both be 4y, right? So I can say that'll be 2 times 4y or 8y, right? For right now, I'm just going to write it as 2 times 4y, so that we can see that we're taking 2 times the front and the back, and then my other, and then 2xy, right? Now there is another element to this problem. Okay? That the bottom is a different price than all the sides. How can I take that into account? The bottom is the 4x piece. Exactly. I'm is going to multiply the bottom by the cost, which is 10, and then multiply all the other sides by 5. Okay, so we can simplify this and make this 40x plus 40y plus 10xy equals what we want to minimize. Now what? Right. Which one do we want to solve for? In this case, it doesn't matter at all. Yeah. So, sure, we can solve for x. So if I solve for x, that's a good thought. But in this case, not necessarily, because x has to do with the base, which costs more than the height, than the sides. So it is probably not going to end up working out like that, but that's a good thought. Alright, so if we solve for x, I would divide both sides by 4y. So we would get x equals 9 over y. Now we'll plug it in. So I will replace all of my x's with 9 over y, or 9y to the negative first. Right, so I can say this is 40 times 9y to the negative first plus 40y plus 10 times 9y to the negative first times y. So before I take the derivative, I can simplify this sum. Just say this is 360y to the negative first plus 40y plus 90. Yeah, these y's would cancel. Now what? Now take the derivative, then set it equal to 0. Yeah. So we'll get negative 360y to the negative second plus 40 equals our derivative. Now we'll set it equal to 0. And again, when we solve, I think it's easier to think about making all of the exponents positive again. So now I end up with 40 equals 360 over y squared. Multiply the y squared up. Divide by 40. Y squared equals 9. So y equals plus or minus 3. Would both of those answers make sense? No. Yeah, only the positive one would make sense here. Now what?
No.
Yes, but we should do the sign chart first to make sure this is a minimum value. Odds are that it will be. So, plug in a value less than 3 into my derivative. So if I plug in 1, negative 360 over 1 plus 40, negative. If I plug in a value greater than 3, it's going to be positive. So it is a min. Okay, that is what we want. So now we'll plug it back in into this one. Right? 36 equals 4xy. So 36 equals 4 times x times 3. So we get 36 equals 12x, divided by 12, and we get 3. So, Mia, you were right.
Well, didn't you say that, like, you spoke about,
Yes, if we're given a constraint of a perimeter, and we're trying to maximize area, that will always be a square. However, in this case, it was a little bit different. We were trying to minimize cost, and the costs of different pieces were a little bit different.
So now we're going to put them back into the
Right. Question says, what is the cost of least expensive tank? Right. So we have the dimensions. We have half of the answer. Right. So our dimensions would be 4 by 3 by 3. But then we also need the cost of the tank. Right. So here we are plugging in 3 for both x and y. So we'll have 40 times 3 plus 40 times 3 plus 10 times 3 times 3. So 120, 240, 60 is 300. Oh, yeah, 90.
About to say.
So
What's that?
330, yeah. So our dimensions are 4 by 3 by 3, and the least expensive tank would be $330. That is expensive.
And it's not that big.
It's humongous. 4 meters by 3
maybe.
meters by 3 meters.
I'm like,
That's a humongous tank.
I didn't know. I didn't really think
That's probably bigger than this.
That's pretty cheap.
Yeah, that's pretty cheap for size.
Wait, how big is it?
4 meters. So that's like
12.
12, yeah, a little more than 12 feet by.
Wait.
So I guess not quite as big as this room. 12 feet by 9 feet by 9 feet.
Okay.
These ceilings are.
I feel like it's big.
You feel like what?
They're probably like 12 feet. I feel like if you stack like one more. To one more
Okay,
each.
if you stack one more thatch, then yes.
Like 6 foot.
So that's like, yeah, so I think it's like, and then, so this is way bigger.
So,
So not as big as this room.
Oh,
Alright. No homework tonight. Okay, we will do practice in class tomorrow.